Hello world, my name is Sean Southwood, and welcome to my first YouTube video on extracting data from a website using Python, or specifically in this case, Collaboratory. And I'm starting with a blank sheet, typing it all out so that you fully understand the concepts in my thinking on what's going on here. And so where we're going to be extracting from today is, no spoilers. We're extracting from Dortzman Databank, vapor pressure, water, which doesn't really matter. It's a website, it has data, and it's stored in some inconvenient format of this table that highlights everything and not the two rows we want of temperature and pressure. And as you probably just saw a second ago, a big part of this is the inspect option. And you're probably not going to understand any of this unless you happen to know HTML very well, and if you do, chances are you're not watching this video. But within this, we will be able to do a fun thing called XPath that will get us from what is on the page to some direct data, the numbers extracted within the code. And so, to start, what I'm going to have is first tell Python what HTML is. And so from LXML, which is the thing that the overarching company that over HTML, or more accurately, the broad category, just import HTML. And then another thing that we're going to end up using right away is something called requests, which is essentially just something that has to do with getting URLs as well. And so run those real quick. And then from there, we're going to just define the URL as a string. And what I'm going to do is actually get the string from a GitHub site rather than the actual thing, because when people scrape data in large quantities, they can mess with the stuff for anti-scraping measures. And so just in case this video blows up or something, gonna be getting the data from a raw file from GitHub. And so we have our URL that just gives us the HTML code. And then within that, we're now going to use the request function within that get URL, which we just defined, .content, which kind of seems like gibberish to, or if this is one of your first introductions to Python coding or the requests in general, but that, I even forgot something that makes it more gibberish. Content equals, I'm defining the variable content here. And you can read the documentation on requests if you want to know specifically how I got that, but essentially that's just requesting the URL. And then I'm going to call this variable tree. It's going to make sense here in a second. And essentially, all this is doing is turning that URL request into an actual string that can be analyzed. Cool beans, right? And then now we're going to finally get to the XPath part that I mentioned before. So I'm going to create a variable here called tstrings, which is going to be a string list of the temperatures. Remember what we're trying to get is this column here and this column here in some sort of useful form. And so tree, because and I'm using the term tree here because that's somewhat of the technical term of, if you look at the HTML code itself here, it kind of divulges into different branches. For a very specific item, it's contained in many different things, and so that's called a tree. And so of the tree that we're looking at, we're doing an XPath, and from here, we're going to tell it where to go, which sounds complicated, especially if you're looking at this giant HTML form. But if you simply just take one of the data points, inspect that, it'll tell you exactly what you're looking at in the code there. And then from there, copy the XPath, paste it, and then it'll say some things that might not make sense to you, but if you just carefully look at the HTML code, you can see we are under a big thing called online DDB form, and within that there are like two div things, and then there's a table, and then the table body is another category for some reason, and there's a TR, and if you scroll through it you can see, oh, the TRs are the rows, and the TDs are specific items within those rows. And so essentially what we're looking at is we have something just in it, and then we have just things that don't really matter, but in the end we have something for rows and something for columns, which is what we're looking at. And so what do we want for the temperature string? We want a list of this column and all of the rows. And so the one for row was the TR, and so we're going to take out the specification for the TR, and then for the TD, this is in column 1, which is what we want. And then for one final part, going to specify that we want the text, which is just a specific XPath thing here. And then one thing that I forgot that it's currently yelling at me for is that this all needs to be a string in order for XPath to fully understand it. And then we're going to do a very similar thing for the pressure string list. Tree.xpath. I'll just copy and paste the same thing here. Make it a string. Take out the specification of what row we want. And for the column, this time we want column 2 here. And if you want to take one of these points and double check, you can see if you copied that XPath, it would be column 2. And then again, slash text function here. Finish the string, and that should be good. And then now we have some sort of string list here, but we don't want strings. Strings, you can't do math with strings. And so we're going to need to make those into floating points because these are decimals. Floating points are the type of numbers that have decimals in them, with technical terminology. And then it'll also be useful to have this in some sort of array where we have temperature and pressure all in the like same item. And so what I'm going to do is import something called numpy. And numpy, if you are unaware, is one of the top dog things to import in Python for any sort of data analysis. You're going to probably see it very often, especially in my videos. And so we're just going to define data. because now we're going to all combine it into one single variable. So within NumPy, I'm going to use an array function and tell it that it's going to be a list, and then we say, hey, tstrings and pstrings. Boop. And then we weren't going to tell it that we don't want it as a string anymore. We want it as type numpy dot float 64, because it has to be a numpy float, because we're dealing with numpy now and not just the general Python. And float is again like a decimal point, a decimal containing number, and then 64 it says to what precision we're going to, and 64 is the normal precision. And so if we just run, and we don't see anything, but if we just say let's go get data, we now have an array of two lists that have floating points of all of the numbers that we wanted. And you can see the widespread application of this if there's a giant table or multiple tables on databases online. This can be broadly expanded to include many things. And next video, we will be using this data to do some fun math. And so stay tuned for the next video, and thank you for watching.